welcome to everyone joining us online. And let's get things started with Arnold Brody and the sky this month. Arnold.
Thank you, Tom. Hello, everyone, and thank you for coming online to see what's up in the sky this month. We currently have bad weather, but once it passes, we can enjoy some of the astronomy highlights happening this month and the first few days of May. The first highlight is the April 4 launch of our 2025 Millennium Square stargazing season along the shoreline in Pickering. Oh, sorry, that was a plug. I just couldn't resist. The next night, we get the first of 5 lunar occultations. Not 1 or 2, but 5. 2 of them occurring on the 16th. There's a difficult Mercury-Saturn conjunction on the 11th, but an easier one with the moon in Spica the next night. There will be a mini-me new moon on Sunday the 13th. Mercury reaches greatest elongation west of the sun on the morning of Monday, April 21, and the Lyrid meteor shower peaks later that night into Tuesday morning. There will be a happy gathering of the moon, Venus, and Saturn before sunrise on April 25. 2 mornings later, Venus reaches greatest illuminated extent and brightness. On Friday, the May 2nd, we have a daily double, our second star party at the Square in Pickering. Oops, I'm sorry, I did it again. On May 3, you can enjoy a close encounter of the moon with Mars along with that occultation, and there's a second meteor shower to round out the 35 days, the Eta Aquarids peak the morning of May 5. And April is prime time for galaxy hunting for your deep sky observing and imaging. I like to combine astronomical twilight, when planets and bright stars can be seen, with night and call it the observing window, which is 9 hours long tonight, but will shrink to just 7¼ hours by May 5, a drop of an hour 46 minutes. Night shrinks even more, losing over 2 hours to the sun, and will continue to shrink until the end of June. So I guess one of the advantages of observing in April is that it's better than May, and there are no mosquitoes. Dark skies will give way to a waxing moon next week with a full pink moon on the second weekend. Prime time for galaxy hunting occurs around new moon in the last weekend of April. The names given to the April full moon describe the transition from winter to the start of spring. I especially like the broken snowshoe moon after the tough winter we've had. Let's begin our tour of the sky with the solar system. As of tonight, Earth, Venus, Mercury, and Saturn lie almost exactly on a line that is just west of the sun, meaning they will be rising in bright twilight. Neptune is not visible, still lost in the sun's glare as it rises. Meanwhile, east of the sun, Mars and Jupiter are visible in the west after sunset, with Jupiter a couple of hours ahead of Mars. Uranus is also in the west, but much closer to the horizon and will set soon after the sun. By the beginning of May, Earth, Venus, Saturn, and Neptune will still share a line, meaning the planets will continue to appear clustered together, with Mercury off to the left or east. Jupiter and Mars are still evening targets as Earth orbits away from both. Our view of Jupiter will be much closer to the sun, so the giant won't be up for long. And Uranus will be lost behind the sun. Tomorrow morning, with the sun only 4.5 degrees below the horizon, Venus, Mercury, and Saturn are low in the east, and Neptune is just crossing the horizon. It's doubtful you can see any of them except maybe Venus. The atmosphere will reduce its magnitude to -3, down from -438, and that's a 70% drop in brightness, so it will be a little bit of a challenge. By May 5th, Neptune and Saturn have jumped up to join Venus in altitude, while Mercury is heading off on its own towards the Sun, shown again 4.5 degrees below the horizon for comparison with the previous slide. Your chances of seeing Venus and Saturn are much better, but Mercury will be very low, losing most of its brightness to the thick atmosphere. But not low for those observing from the southern hemisphere, where the ecliptic and the planet's orbit stand almost vertically. On May 5, these four planets can be found 4 to 13 degrees higher in central Chile than from southern Ontario, and much easier to spot before dawn outshines them. Saturn, for example, will be 12 degrees higher there than seen from Toronto, and can be observed 16 degrees above the horizon before the end of night. Mercury reaches greatest elongation west of the Sun on Monday, April 21. For those down under, Mercury reaches its highest in the morning this year, and you can observe it before the end of night. For Toronto, we never get that opportunity. That would be amazing. It's always low and close to the horizon for us in Toronto, and Mercury will be fighting through civil twilight when it's clearing the horizon for us. If the seeing is steady and the horizon free of haze, you can see the phase of Mercury 3 days shy of dichotomy with enough magnification. A minus violet filter may help reduce atmosphere-induced color fringing. 1 week later, Venus reaches greatest illuminated extent and its brightest for this morning star appearance. You can see Venus in its waxing crescent phase with enough magnification and good conditions. There will be no moon interference that night. Again, a minus violet or fringe killer filter may help. Saturn will be too difficult to spot at the start of April as it clears the horizon. But by the beginning of May, Saturn will have pulled far enough west of the Sun to make it observable in nautical twilight. We crossed through Saturn's ring plane a few weeks ago when it was hidden behind the Sun, so we will get our first chance in early May to see its rings since then. The rings will remain thin and look this way all year. When the rings are close to edge on, with a modest telescope, you have a good opportunity to spot some of Saturn's moons besides Titan. You can probably subtract 1 or 2 magnitudes from those shown here, depending on how low Saturn is in the sky. But it will climb higher throughout the spring and summer, so it will be even easier to spot them higher up. And we are currently about as far from Saturn as we get at opposition this summer on August 21. It will appear 20% bigger and almost 1.7% brighter. And the same goes for its moons, too. Neptune, like Saturn, will be too close to the horizon prior to sunrise to be visible in early April. By early May, it might be possible to spot its tiny blue disk with sufficient magnification, but I'd say that Neptune is not ripe for viewing yet. We might want to wait until August, when it will be easy pickings at the start of night. Turning our attention to the evening sky, after tonight's meeting where it's not raining like it is here, you can find Mars holding hands with Pollux, Jupiter lingering between the horns of Taurus the Bull, and Uranus close to the horizon west of the Pleiades. That's the moon next to Jupiter, right here. All 3 planets are in prograde motion heading eastward. Mars will cross from Gemini to Cancer in 10 days, while Jupiter continues to climb up through the bull's horns, and Uranus slips below the horizon towards the Sun. The angular size of Mars is under 10 arcseconds, considered the smallest size needed to see any detail, so it will just be a fading rusty dot until we finally lose it to the sun this fall. Being so big, Jupiter can still show some detail, though it will set soon after the sun by the start of May. In other words, this month is your last chance to observe Jupiter before it's too close to the sun. We are as far as we can get from Jupiter while still able to observe it. Jupiter reaches superior conjunction on June 24. If you observe Jupiter at 9 p.m. on Saturday, April 12, you can watch Io exit Jupiter's shadow. Even though Uranus is up briefly before sunset at the start of April, it will be so low, the atmosphere will dim it below naked eye visibility. And that rounds out our tour of the planets. On to the moon. The moon will reach first quarter on April 4, just in time for Millennium Square. Watch how the moon shrinks as it reaches apogee at the same time it reaches full, making this a micro full moon. I suggest you go out and have a look at it. You will never see a smaller full moon. Notice the moon approaching and enlarging as it reaches third quarter. And the darkening moon looms ever closer as it approaches perigee and new moon at the same time, making this a super new moon. Reaching into the first week of May, we have first quarter on May 4, when the lunar X and V should be visible. This chart plots April's micro full and super new moons at the peaks of the biggest oscillations of the apogee-perigee wave in 2025. This is how the lunar X and V should appear on Sunday, May 4, around 10 p.m. Mare Crisium is one of the targets in the Explore the Moon observing program. The best time to study it is when the sun's angle there is low, which is 2 nights after full moon. So instead of cursing the almost new moon, here's a reason to check it out. The Sea of Crisis has a very flat floor with wrinkle ridges called dorsa noticeable along its eastern shore. There is a small protrusion of mountains sticking like a thumb into the Mare's west side. Look for a pair of ghost craters near the eastern shore of the Mare, yerks and licks, around 30 kilometers each in diameter. They are filled to their rims with lava. You can spot a few fresher craters around 20 kilometers wide or smaller, such as Picard, Pierce, and Swift, with their western rims lit by the setting sun. And see if you can detect the patterns of light rays stretching across the floor of the Mare Crisium. They are ejecta from the impact that dug out crater Proclus. The Blue Moon lander touched down in Mare Crisium on March 2, making Firefly Aerospace the first commercial company to soft land on the moon. After its official 2-week mission ended after sunset over the area, there was around 4 hours of battery life left, which the mission team saved to turn the lander back on and have it look back at Earth and capture this solar eclipse at the same time we were enjoying the lunar eclipse last month. A mass concentration, MASCON, or gravitational high, was identified in the center of Mare Crisium from Doppler tracking spacecraft on 3 gravity mapping missions. The monster asteroid that created the Mare is hiding just under the surface. The sun climbs the southern sky by 11 2/3 degrees from now to May 6. Its highest point is drifting eastward as our orbital velocity decreases as we pull away from our perihelion in early January. Our distance from the sun is exactly 1 AU today and will increase by 0.009 AU around 1.4 million kilometers by May 6. There was significant solar wind last week from a large Earth-facing coronal hole in the southern hemisphere that is now rotating out of view, while another one rotates in. And a very active group of sunspot regions is rotating into view as well. One in particular, active region 4048, grew rapidly as it swung into view and has a strong chance of producing flares with coronal mass ejections, CMEs, as it moves towards the meridian. Region 4048 has been classified as beta gamma delta, meaning it is complex, with positive and negative spots mixed all over the place, including some inside the same penumbra. This is considered promising for CME producing eruptions. The latest notice from the Space Weather Prediction Center for this week includes radio blackouts resulting from regions 4046 and 4048, and geomagnetic storms this weekend from solar winds coming from the coronal holes. We are at solar maximum now and may stay there for a few more months, so the prospect for auroras remains good, along with radio blackouts for first responders and dispatch operators, and elevated radiation for airline personnel and frequent flyers. Comets? Well, there currently aren't any comets bright enough for easy observation. According to Crniver Observatory in Croatia, the only comet with reasonable magnitude, the one at the top, is not observable because it's in Pisces, where the sun is at the start of spring. So there are no bright comets for us to observe right now, but there are some meteor showers that we can enjoy. The first is the Lyrids, or April Lyrids, and it's the first we've seen since the Quadrantids in January. The Lyrids are so named because the radiant is close to Vega, the brightest star in Lyra. The shower is debris shed by Comet Thatcher, and the Lyrids have the highest ZHR, or zenith hourly rate, from the debris of a long period comet. Thatcher has a 415-year orbit. Anything over 200 years is called long period. The prospects for viewing the Lyrids are very good this April. The radiant begins to rise soon after sunset and climbs almost to the zenith. A 24-day-old moon doesn't rise until 4 in the morning. The April Lyrids have the potential of producing fireballs. Outbursts occurred in 1922 and 82 when rates peaked at 90 an hour. And there was a famous outburst in 1803 with 700 an hour. That's like 12 a minute, or 1 every 5 seconds. Seeing that would be awesome. It was a storm in 687 BC that caught the attention of Chinese observers who recorded it in a daily narrative, Zuzan, like their Facebook of the time, making this the oldest known shower. The author wrote that the fixed stars were washed out by the brightness of the meteors that fell like rain at midnight. By the way, here's the radiant of the next shower rising, the Eta Aquarids. It peaks in early May. The Eta Aquarids have a broad peak. Activity is good for a week centered around the peak, predicted for the night of May 4 to 5, Sunday night into Monday morning. Here we see the radiant rising just before dawn on Monday, May 5. A first quarter moon sets a few hours earlier and will not interfere. This shower favors those watching from the southern hemisphere where rates can reach 60 an hour, about 1 a minute. Above the equator, the rate drops by half or more, around 10 to 30. And now grab your popcorn. It's time for Close Encounters. We have 5 lunar occultations and 3 conjunctions this April and early May. The first occultation is just 5 minutes into the start of Saturday, April 5, when the first quarter moon passes in front of 47 Geminorum, a fiercely hot main sequence star of spectral class A4. You may want to use moderate magnification, around 120 or so, to keep the illuminated half of the moon out of your field of view during the occultation. The next two occultations occur on the morning of Wednesday, April 16. The first occurs at the stroke of midnight when the moon covers B Scorpii, not to be confused with Beta Scorpii. B Scorpii is even hotter main sequence star than 47 Geminorum, classified at B1. The bright limb of the moon will pass before the star as Monday night switches to Tuesday morning. The second occultation that morning occurs 5 hours later and is interesting because it involves an eclipsing binary whose stars are again hot class B1 stars, almost at the very top of the HR main sequence branch. Together they shine at magnitude 2.85, making Pi Scorpii the brightest of the 5 occultations. The occultation occurs just before 5 a.m. and ends just after 6, from 4:55 to 6:04. And Pi Scorpii binary orbit each other with a quick period of just 1.6 days at a separation of just 0.071 astronomical units, and that's only 18% of Mercury's average distance from the Sun. If we're lucky, the pair will be positioned like this, so we can see the double star disappear in 2 steps as the moon travels across in this direction, one out then the next. And that would be interesting because if the stars are more vertically stacked, they would seem to disappear at once. But if it's like this, we may be able to watch this star, this binary pair, wink out in 2 steps. The fourth occultation coincides with a conjunction of the moon and Mars, with the god of Mars risking a sting from the Beehive cluster. With a wide field of view, you can watch Assalis Borealis wink out behind the dark limb of a first quarter moon in a sparkling scene with colorful Mars. The next night, we see the final occultation with 8 Leo, a faint 5.7 magnitude star, spectral type K1. The occultation will occur around 15 minutes into midnight and fairly high. Use around 200 times magnification to keep the bright side of the waxing moon out of the eyepiece field. As for the conjunctions this month, the first on April 11 with Mercury and Saturn will occur in fairly bright morning twilight. It might be too difficult, but much easier for those south of the equator. The following day, you can easily watch the nearly full moon rise just a half a degree from brilliant Spica. On Friday, April 25, start your day with a smile with this happy face, made by the moon, Venus, and Saturn rising in civil twilight. Good day, eh? For deep space, springtime is galaxy time. If the ecliptic of our solar system were parallel to the galactic plane, we'd see the Milky Way in the night sky all year round. Instead, the ecliptic is tilted from the galaxy by 60 degrees. This means there will be seasons in which our night sky faces away from our galaxy. Spring is one of those seasons when our view is out into intergalactic space. The hundreds of galaxies in this scene are all 12th magnitude or brighter, waiting for you to find them in moderate to large telescopes. You will usually find multiple galaxies together in your eyepiece. The concentration of galaxies next to Virgo's raised hand is the Virgo cluster, containing up to 2,000 galaxies, around 54 million light years away. Among the cluster's members is a remarkable chain of 8 galaxies known as Markarian's chain. named after Armenian astrophysicist Benjamin Markarian, who in 1961 published a report in which he used statistical math to conclude they are not a chance alignment, but a real physical system. In the middle of the chain are two interacting galaxies, NGCs 4438 and 4435, coined the eyes by 19th century observer L.S. Copeland. The eyes look back at us with a slight squint because they are tilted just 15 and 20 degrees. The pair is number 20 in Halton Arp's catalog of peculiar galaxies. Peculiar primarily due to 4438's distorted shape caused by interactions with neighboring galaxies in this dense region. 4438 was robbed of significant gas and dust, cutting off future star birth. As you can see here, there's a significant amount of dust that's been ripped right out of the galaxy, and you can see so much of its gas spilling out all over the place. And it was likely due to a high-speed collision with M86. A bridge of ionized hydrogen connects the two. Meanwhile, neighboring 4435 was once a barred spiral galaxy. 100 million years ago, it passed within 16,000 light years of 4438, and the tidal interactions transformed it into a barred lenticular galaxy and ignited starburst activity in its central region. The faint nebulosity surrounding both galaxies was recorded in the sketch of the eyes by Michael Geldorp in the Netherlands. The new moon weekend of April 26 and 27 will be a good time to have a staring contest with the eyes and see if you can detect any of the nebulosity around them, especially NGC 4438. They will appear similar in brightness, with 4438 not as narrow, tilted 5 degrees more than its neighbor 4435. And that's all I have. Are there any questions?
All right, then. Well, thank you very much, Arnold, for a wonderful look at what's coming up in the sky this month. Do we have any questions from our online audience?
Well, there was one question. There were a few comments. Grace said that one part of your presentation reminds. Hello, can you hear me? Yes.
I
Grace
do,
said,
yes.
One part of your presentation reminds her of one magical night when Tony, Brianna, and Tom were at the CAO, and Tom showed Brianna the moon. He used the moon atlas too. She still speaks fondly of it. Also, I love your sound effects, and I was wondering how many decades or centuries or millennia can we expect a meteor shower to last? For example, the Perseids.
I would imagine that it's pretty close to indefinite, as long as the meteor streams left behind by those meteors don't get perturbed out of space, out of their locations by, let's say, the planet's gravitational tugs on those streams. Sometimes they do move. The streams will change based on certain harmonies with the planets. So I guess they will eventually drift, and maybe a different meteor stream will drift into our orbit instead. So you got to remember that these orbital paths that the comets take are terrific, and the debris that they leave are on the same orbit. So they will follow way out and come back. All of that debris, it's all in the same orbit. And as long as we continue to fly through that debris field, we will have the meteors. So it's up until such time as the meteor streams get perturbed out of our orbit. Until then, It'll always happen, I would say.
Yeah, and are
That's
the
my best
comets
answer.
in a constant state of disintegration, or is it a?
They are constantly disintegrating, and eventually, if they're close enough to the sun, they will lose enough material that eventually they've run out of volatiles. Sometimes they get so close to the sun that they get torn apart, and then they will disintegrate rapidly. But the debris field will continue to circle around and around and around. So the comet could be gone, but we will still pass through whatever it left behind.
Eric Briggs just had a comment. Pi Scorpii. That would rock.
Yeah, we've got so many stars in this presentation that happen to be B1. I mean, they're some of the biggest stars on the HR diagram that are still main sequence. They don't last for long, 100 million years maybe. So the fact that we've got so many lined up for looking at this month is remarkable.
Okay, that's it for the questions and comments.
All right. Well, thank you once again, Arnold, for a wonderful presentation.